Hi there. Today I want to do a quick video on how to get started with RGB lighting. So maybe this is your first PC build ever, or you've built lots of PCs and just never have done RGB lighting in the past. So when you first start kind of looking into it, there's a number of different connection types, a bunch of different controllers, whether that be motherboard control or a whole bunch of external controllers, not to mention the multitudes of RGB devices that are out there, which is pretty much everything that you can stick in this PC can come with RGB lighting. And so it can be just a little bit confusing and overwhelming at first to understand the technical jargon and vocabulary that you're going to encounter out there. So hopefully this video will serve as kind of an orientation guide to help you get started and making some good purchasing decisions. So let's go through this step by step. I'm already assuming that because you're here watching this video that you've definitely got an interest in RGB lighting. So one of the biggest things I read everywhere is that, well, RGB lighting doesn't add to the FPS of your games or do anything for the PC. Well, no, of course not. But that's really kind of besides the point. So, why would you use RGB lighting? Well, first and foremost, it's just a really cool aesthetic. If you look in other industries out there, RGB lighting is used all over the place because it just looks nice. It's just got a cool look to it. So, and being a PC enthusiast, right, you get to pick and choose what technologies and functions you want to explore, whether that be overclocking, heating and cooling, benchmarking, whatever. You get to choose. For me in this channel, really I've taken a look at a lot of RGB lighting products just because I kind of think it's cool and I like exploring that. So anyways, we'll go through this step by step and take a look at it. All right, so let's go ahead and talk about some of the key concepts and vocabulary terms you need to know when we're talking RGB lighting. The first and foremost, and probably the most basic, is what is an LED? LED is a light emitting diode, which basically is a solid state semiconductor device that when current is passed through it, depending on the material that it's constructed with, it will glow and emit light of a certain color. So an RGB LED, it's basically just the same thing, just in the package you've got three LED elements in it, and they're red, green, and blue. Basically, you vary the level of current to each of those, which gives you a corresponding brightness. And then when you mix all three of those colors together, you get a resulting color. I think there's up to like 16 million colors that you can generate. Not all colors reproduce correctly, like browns and pinks, and even sometimes orange. I've seen a few of those not be really accurate, but you get the idea. And so that's really what we're talking about is RGB LEDs. So moving on, the next term you're going to see thrown about out there is 50/50. And when you see 50/50, what it's referring to is the package size, the size of the LED light itself. So, there's a lot of information and discussion to be had about how bright your strip's going to be depending on what size LED package and how dense they are. For your purposes, you're not really going to need to worry about that. Basically, just when you see 50/50, that's the most common one. I'll put a picture of that up on the screen here. That's what we're talking about. I've seen lots of smaller ones that they're not really designated when you see those. 50/50 is the one that I see talked about. Just know that it's just the physical dimensions of the LED itself. So the next term you need to be familiar with, and you will see this thrown about as well, is WS2812B. And what that refers to is the actual chip that is on board the LED. So I'll expand on this concept here in just a minute, but WS stands for World Semi, and I think they're one of the original manufacturers of LEDs, and they kind of maintain a database. I'll put a link in the description below to their website. You can go learn a little bit more about these. You can look at WS2812B, get some of the wiring schematics for it, and some more basic information on it. Now, it's important to note that all of this, you really don't need to know it necessarily to do RGB lighting. It's just good because, in the product pages and specs, you're going to see these terms thrown about. It's good to know what they mean. But WS2812 simply refers to the little teeny controller chip that's embedded in that LED package, which we'll talk more about in just a minute. So there are other types, obviously, of controller chips out there, but WS2812 is really the standard that you're going to see. And so the next set of terms that you're going to see thrown about is ARGB or addressable RGB or digital RGB. I've seen all three of them used. Sometimes the header on your motherboard will show ARGB, and they really all mean the same thing. What it means is that you can control each LED individually. And so basically, because of that little chip that is embedded in each one, you can kind of talk to that chip individually, and you can set a different brightness or a different color all across the strip. So you can talk to every light individually. So all of the fancy lighting sequences that you see, all of the different effects and everything that looks really cool, that's all going to be addressable RGB. But they all just fall under that same banner. And so the other type of RGB out there, I'm just going to call it 12 volt RGB. And what that means is that there's no individual controller in each LED, meaning that you can control the strip as a whole. It's got a different connection, which we'll go over in just a second, but you're basically just adjusting every LED at the same time. So the whole strip can be red, the whole strip can be blue, but you can't talk to each individual light. There's one more type of RGB light that you might come across out there. I really can only recall one. I think I had a motherboard that had this header on it, and it was RGBW. RGBW means red, green, blue, and white. And so white is generally reproduced by just turning all three RGB elements to their brightest level. And that kind of generates a white light. So I've seen it kind of commented online that that's not really a true tone of white. And so there are some applications that might require that fourth LED, and that fourth one is an actual white color. And I think that one header had that connection. I've never actually used it, and I've never made any comparisons between an RGBW white and just RGB white. So from my experience, and I do actually like to turn some of my RGB lighting white on occasion, to me it looks good enough. I don't know that I would have any benefit from going to a white one. So maybe it'll be fun to play with that and see if there really is a difference. But anyways, be aware that you could come across that out there. So let's go ahead and talk about the two main types of connections that you're going to find out there. The first being a 5 volt connection, the second being a 12 volt connection. I'll talk about the pinouts to each of these in just a second and kind of how they're wired up. But this will be one of the more important things to take away from this video. And what these two connectors really kind of mean, at least this is how I kind of associate them, is the 5 volt connection is the addressable RGB connection, or addressable ARGB, or digital is how you'll see it referred to by any of those names. That's going to be the fancier lighting that you see, all of the really cool lighting schemes and effects. Those are all going to be 5 volt ARGB, meaning that you can control each RGB LED individually by itself. You can turn each one a different color, and you can do all sorts of really cool stuff with it. The 12 volt connection is going to still be RGB LEDs, but you'll be able to just control the whole strip with the same color. So it can all be blue, it can all be red, but not at different times. And so anyways, the 5 volt RGB is probably the more common out of the two. I really haven't done a whole lot with 12 volt RGB, even though it works. Most motherboards will have both connectors, but not all of them. I've got a mini ITX board here that doesn't have both. It just has the 5 volt connection. And so anyways, again, we'll talk about the the pinouts and kind of why it is like that here in just a second. But the basic reason is, as you recall in the last section, we talked about the WS2812B IC driver chip that's embedded into that. Well, that chip sits on each individual RGB LED. Well, that's a 5 volt chip, and that's kind of how you communicate with it. So you don't want to throw 12 volts to it. Now, if you start Googling this, there are WS controllers out there that will do addressable RGB on 12 volt signals. But as I kind of delve into some Christmas lighting and things like that, that's really the area where I see that type of stuff, not in the PC world. And so now there may be exceptions to that. People may have gotten that to work. There may be some other things I'm not familiar with. But as a general rule, just associate the 5 volt connector with the addressable RGB, 12 volt with non-addressable RGB. But anyways, those will be the two main styles of connections. And every RGB product out there, most of them will note whether it's a 5 volt or a 12 volt. But if it says like it's digital RGB, you can assume that it's a 5 volt. Okay, so let's go ahead and talk about the 5 volt pinout and the connection itself. Now there is kind of loosely a standard to these things, but not every manufacturer is following it. So, but if we're talking about what is kind of considered the standard out there, it's going to be a 3-pin connector. Now, actually on the motherboard, there's 4 positions for pins, but one of them is not populated. So the signals that you get over those pins are going to be a voltage signal, a data signal, and then a ground signal. Now, how this kind of works is we apply voltage, across the string of lights, and then we apply a data signal across it because we can talk to each WS2812B controller individually. We know where they're all at, and through that we tell it what values or what voltages to allow to each individual RGB component or element of that package, thus setting the color of that particular light, and then so on and so forth. And we can send all that data down that port to each individual chip, thus we can get all of these fancy customizations, all these cool lighting effects. And so that pinout is pretty standard. I would say most of the stuff out there is going to have that particular pinout to it. Now there are exceptions, and we'll talk about those. So Corsair uses the same exact signaling, of course, but they've packaged that connector into something proprietary to them. Gigabyte has what they call a VDG port. It's still the same 3 signals, but it's more similar to the Corsair connection. Now I've done a video on how to get the standard 3-pin stuff working in Corsair iQ. It is not perfect, but it can be done. Basically, you just there's adapter cables you can use to kind of redirect those signals, between one controller and products that I won't say aren't standard, but just use a different style of connection. And so there's more information on that as you get going. Anyways, the 12-volt connector is a 4-pin connection. What you're doing is just on the red signal, you're talking to all of the red RGB elements as a whole, across the whole string. Same with the green, same with the blue. So you're just sending those to the entire string. So the whole string just gets the same signal. And that's pretty much it. I really don't do much with the 12-volt stuff. And I have one LED strip that's 12 volt. I was doing a demonstration of that. But really, you can do everything that you need to do with the 5-volt stuff. And that's the way more common. You get the cool effects. You can customize and address everything individually. So my opinion really is, unless you've already got some 12-volt stuff and the right connections and everything, if you're going to buy new stuff, just get the 5-volt stuff. Unless you're saving a ton of money by going this, but even some of the 5-volt stuff is relatively cheap. Now, some of the more inexpensive RGB stuff you're going to find out there, like GIM, and there's about 1,000 other different manufacturers of some of this more inexpensive stuff. They will utilize that 3-pin connection to the controller, but the individual fans and the components and the strips are all going to use kind of some of their own proprietary connections, which we can get into in another section here. Okay, so now that we've talked about the 5-volt and 12-volt connections and the pinouts for those, let's go ahead and talk about the controllers that you're going to use to control that lighting. So the first thing you probably think of, and the most common way I think most people are controlling this, is going to be through their motherboard controller. Most of these connections that we talked about sit on your motherboard. You'll have to consult your user manual for any specific motherboard and see if you have them. If you do, then you do have a controller built in and ready to go. And basically, the 4 manufacturers I think of when I look at this are going to be Asus, MSI, Gigabyte, and ASRock. And they all have their own corresponding software. Asus has the AuraSync, MSI has Mystic Light, ASRock has Polychrome, I think is what they still call it, might be something else, but and Gigabyte has Gigabyte Fusion. I've used all of them at one point or another. And so basically, it all just works. And if your motherboard has built-in RGB lighting, a lot of them do, they have their own elements right on the motherboard. One of the big advantages you get is if you use that internal controller, is all your external lights will match whatever those internal lights. And we'll talk more about kind of the interconnectivity and intercompatibility here in just a second. But so anyways, your motherboard controller is probably one of the more obvious choices to control that. If your motherboard doesn't have that capability or you don't want to use that, there are some other options that you can choose. Corsair, of course, has a lot of RGB options. This is the Commander Node Pro. This basically is a SATA powered controller, and then it connects up to a USB header on your motherboard. Then from here you can plug in all the RGB lighting elements, and they make a couple of other different controllers that embed themselves into this ecosystem. I've done some videos on that in the past. You get a lot of capability with that one. On the pricier end, of course, Razer Chroma makes their own internal controller. I've done a review of that recently. And basically this is the same thing. Power it up, connect it to the USB, and you get the 3-pin 5-volt connections. And NZXT is kind of the same way. They've kind of got their own little connector going there, but basically plug that in, go to USB, and you can attach lighting through that. And I've got another controller from RGB that kind of does the same thing. It's similar to the Commander Node Pro. I haven't looked at that one yet. I'm going to do a review of it. Beyond that, and there are probably a couple of other these out there that you can use, and they all have their own software. Corsair has IQ, Razer Chroma, of course. A lot of you have probably used that with keyboards and mice. And a couple of these integrate like with Philips Hue light bulbs and things like that. NZXT has their own lighting control software. And some of these will be cross-compatible, say with like the ASUS software or the ASUS controller. You can talk to some of those lights through there. Moving down the chain a little bit, you'll find a lot of these in the more inexpensive sets. Sometimes you can get a full controller, fan, or LED kit, such as GIM. I've done some of the reviews of these products. This is like a whole kit here. These use kind of what I would just consider to be more of a standalone controller, which these don't make any USB connection. There really is no software control to these, with some exceptions, which we'll talk about in just a second. But these come with a remote. And so basically you just power those up with a SATA connector and then plug everything into these, which is going to usually use this 6-pin connector, which basically this just embeds the fan PWM connection or the fan power connection and the RGB elements. This also has some LED connections here as well, but this is going to be proprietary to like GIM and some of the other more inexpensive stuff. But you then would control that RGB with the remote. Now this particular controller, not all of them have this, but some of them do. It does have a port which will connect up to that 3-pin 5-volt connector. And what it takes from that is the RGB signal from it. And so basically you can put this in a mode where it will listen to this port. Then you could use this, to use, like the Aura Sync software to go ahead and control this through this controller. So it works pretty good. This one also has a button where you can use your reset switch to change the mode on it instead of the remote, which is actually a pretty nice touch. I like that feature. So there are many of these out there, and on this channel I've reviewed a whole bunch of this kind of, these more inexpensive kits. They're usually fairly adequate, pretty nice. I'll give you some more opinions on that here in a minute. So anyways, that's kind of, the controller styles that you're going to find. There's probably going to be others out there that I haven't played around with a whole lot, but that's kind of what you get. You get to recap, you get the choice of your motherboard. You can use some of these aftermarket kind of add-on controllers, the Corsair, Razer, NZXT, and then you come down to your standalone stuff, which is usually on the cheaper end. Not all of it, but it's usually on the cheaper side. Some of these here are going to be more expensive. They're definitely a cost beyond your motherboard, but like the Corsair RGB ecosystem is probably the most expensive out there, but it comes with some advantages too. Okay, so now that we've talked about some of the basic controller types that you're going to run into out there, let's talk briefly about the interoperability and compatibility issues that you're going to encounter. And so one of the main problems with RGB lighting when it pertains to PCs is that every manufacturer just seems to be off doing their own thing. There really is no single concise control scheme for it all to pull all of the manufacturers together. So there is bleed over. And but it's impossible in one single video to kind of go through all of the different combinations. You'll have to research a little bit of that out for yourself. In so much as that, like ASUS Aura Sync will cover a multitude of different types of controllers, and vice versa. Corsair I think will work with some of the Aura Sync stuff. You can get some cross compatibility there, but it's hard to know what that will be until you do some research. And that's kind of been one of the main problems, is that like for this PC, for example. I've got some motherboard LED elements that I have to use their software to use. The AMD Wraith Spire heatsink is a USB connection, and I have to use Cooler Master software to control that. And then not in this PC here, but in my daily driver I use Corsair lighting, so I've got to use IQ to do that. And so that's 3 pieces of software that I need to control all of those lighting elements, and then they're all different. You can't really sync them together. And so I've really personally just kind of conceded the fact that that's kind of the way that it is, and I've just kind of set some of the more basic elements to kind of a neutral color, and then Corsair IQ is what I use to control the majority of my lighting and fans, and I guess really fancy sequences there. So I've been able to make it work. It's not a big deal. It's just, it would be nice if there was a single way to control everything. Now there are pieces of software out there that are attempting to do that. One of the main ones that I've seen is JackNet RGB. It's very overly simplistic. Basically, you're going to set it to just a control light, and then JackNet will just try to talk to everything else in your ecosystem, and it can kind of talk to a whole bunch of different types of controllers and schemes like that. Anyways, it's overly simplistic, but it does work. There's OpenRGB out there, there's Signal RGB, and I haven't played a whole lot with those, but I know that there are efforts underfoot to kind of cure this problem. So anyways, just be aware of that. So let's talk briefly about how the controller actually communicates to all of the individual RGB LEDs on a 5-volt addressable strip. So it uses a communication mode called NZR, which is definitely beyond the scope of this video. I'm not an expert in that field, but if you want to know more, there's plenty of information on the internet. But an oversimplification might be that each RGB LED needs 24 bits in order to set this wide range of colors. And so the controller needs to know up front how many RGB LEDs are in this particular strip. And based on that, it will create the data packet, and it will send it to the first WS2812 chip, which strips off its 24 bits and then just kind of sends along the remaining amount. And then each RGB LED along the line just strips off its portion and just continues down until it's done. And then it just continues to go. But the important piece of information here is that in almost every case, you have to tell the controller how many LEDs are here. And so based on that, it knows how to kind of construct this data piece. Now, on most of these controllers, I can reduce that number down. And as I go down into the strip, say there's 12 LEDs on a strip, and I tell it there's 8, it only lights up the first 8. And so, but the real important piece to this is that each individual RGB LED has actually 4 connectors. We talked about this being a 3-pin, 5-volt data and ground, but each RGB package itself has 4 connections. Now that last one is a data out port. And so basically it's what I would call daisy chaining these together. So the data goes in, flows through the chip, and then goes through the data out port, which is then the data in port on the next element. And so as we talk about this 5-volt RGB header on the motherboard specifically, that's a single string of lights. Now, if you connect a fan to that, a fan is essentially just a string of lights, that are all daisy chained together. Now, the strips, at the end of a strip, so you have like your input, and then on the end it has another connector where I can easily plug in the next strand of lights. And so that daisy chains them together, and then I can tell the controller that, okay, you've got 24 LEDs in here now, and so on and so forth. Up to the limitation, you'd want to consult your motherboard manufacturer, because every port's going to have a limitation as to how many LEDs it will address. Now that is probably most often power related, not I don't know what the limit is of how many the controller can how big a data packet it can actually send. But anyways, so RGB strips are going to just all daisy chain together. Now, a lot of devices that you'll see, certain fans and things like that, they don't have that ability to daisy chain. You plug it in, and then there's no way, there's no second connector to plug anything else in. So in a lot of cases, products will use what I would call a splitter. Now, if you go onto Amazon or Newegg and you find all these $10 to $20 RGB ports, where you just plug it into this single port here, and then it gives you 10 additional 3-pin 5-volt ports. The super important thing to know about that is that's a splitter, it does not daisy chain, so you don't get the ability to individually then address all of those at any given time. What it does basically is take this one signal and just duplicates it to all of the other ports. So I can demonstrate this point by using the GEM controller here. Now I've got the controller connected into my 3-port 5-volt header on the motherboard, and I've got it set to 0 RGB LEDs on the software. So let me increase that by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now, the important piece to take away from this is that the fans lit up together all at the same time along with the controller. It's only got a handful in the controller. But the point is that this is what I would call a splitter. So it takes the signal from that header, just injects it into the controller, and the controller just kind of broadcasts it out to everybody. So, you know, the first LED on all 3 of these devices gets that same signal. So you can't control these like individually together. So when you buy these, you know, $10, $20, you know, what they call hubs oftentimes, you know, on Amazon and Newegg, they're really splitters. So just realize that every fan's going to do the same exact thing. You can still do fancy elements, you know, rainbow and all these things, but they're doing it essentially at the same time. You can't control each fan individually. And so you just have to control them all at once. So, you know, some of the, you know, Corsair and things like that, they get around this by using controllers, and all of their stuff is daisy chained. Now, a couple of solutions I've seen to this online is like, now this motherboard in particular, this ASRock one, has 4 ports, 4 RGB headers, 2 5-volt, 2 12-volt. Would be important to know that you can use those all at the same time using the software. You can do all of them at the same time or do them individually. But you could take these 2 5-volt headers, plug in 2 5-volt splitters, and then at least you could get, you know, dual colors and dual effects on individual fans, but you would just still get those 2 channels. Again, Corsair defeats this kind of in a more you know, fanciful way, you know, with the software and the hardware, because the component is actually daisy chained. Like their fans are actually daisy chained around into one big string. So I can turn any RGB LED element on in the system. But then the software kind of abstracts that and takes that into account, and then kind of, you know, gives it to you in an easily recognizable pattern so that you can control everything in any way that you want. So anyways, all right, so, but anyways, the big takeaway is be aware of splitters. Splitters or daisy chain, that may have an effect on how you want to do it. Okay, so now that we've talked about some basic terminology about, you know, RGB lighting, the different connection types, you know, the controller styles, you know, the motherboards, the controllers, standalone, etc., and the types of software that you're going to use to control it, and some of the problems you might run into with intercompatibility. You know, really, how do you get started in it? What's your first order of business? Well, I think for everybody, they should really assess what is it that you want to do with RGB lighting. How fancy do you really want to go? You know, and do your research. Go out there and, you know, look at just crazy RGB lighting setups, and, you know, try to, you know, make note of what do you like, what do you not like about, you know, everybody's setup. And then try to ascertain, you know, what manufacturer is this, how did they achieve this, and what products might I need to do this. And then, you know, you can kind of work from there, having armed with a little bit of knowledge. And then, you know, if you really just need to go basic, you know, you can get away with just a strip or two of, you know, even 12-volt lighting, and, you know, or, you know, some cheap 5-volt strips, and you can get some really cheap stuff. So, you know, or if you really need to go full out and you need the full complement of everything, you know, Corsair makes just about every RGB product you want to get, and, you know, but they're very expensive. Of course, GIM's on the very low end. You can get this whole setup here with like 5 fans and some, you know, LED bars for $50, you know, whereas one of the fans for Corsair is going to be $35, $40, depending on, you know, when you buy it. So anyways, I think that's the first step, is to really know kind of what you want, and then from there take a look at what you already have. Do you already have a motherboard that has the controller built into it? If so, go look at their software and see if that meets your needs. I'll be adding some videos here shortly. You know, we'll go through all of those pieces of software and take a look at what they can and can't do. And so take a look at that and see if that controller will meet what you want, and then, you know, determine what products you need, which fans you kind of like. You can go out there. I've done a ton of reviews of different fans out there, just start looking at all the different styles, and you can kind of narrow down pretty quickly what styles you like and what people are doing. And then, take stock of what you already have, see where you can save money, and then, set your budget. And, Corsair is going to be on the top end. That's going to be, super expensive stuff. You can spend $1,000 on RGB lighting there, if not more, or anywhere underneath that, of course. But, you can get down into the GIM simple stuff that doesn't give you as much capability. But I think all of this was like $50, $60 on Amazon. And so you can really make it all work. It just depends on what you want to do. So, all right, well, that is going to do it for me today. If you have any questions and I can be of help, please let me know, and I will do my best to answer comments and questions as I can get to them. If you have any additional tips and tricks and advice for people doing RGB lighting, please let us know. Obviously, there's many different products and ways and techniques and different ways of doing things out there. So let us know what your experiences are and what's worked for you and what hasn't worked for you. And welcome all comments. And anyways, go out there, build something amazing, and let us know what your experiences with it are. So I will see you in the next video. Bye.